Question, tell me your name again.
Debbie.
Debbie asked me, the tangent grade conversion chart. So you got the angle to grade conversion. All I did that day, well, I got 3 answers for you. I did a Google search that day, but we needed it in class.
Okay.
I just went to Google, I said tangent table. Now, that's one answer. I'm going to give you 4 answers. Damn, we have 4 answers. There's one answer. The second answer, is it recording? So my nose look even that large back here. That's one answer. Second answer, on the homework sheet, I've got one hyperlinked. So you can go to that homework page, and if you go down to the bottom, you'll see a hyperlink for one. Third answer is, at the bottom of that homework page, it shows you how to do it in your calculator. There's a command called the arctangent that does it in your calculator. I promised you 4 answers, didn't I?
Okay, that's all right.
Well, there's 3. If I think of the 4th, I'll bring it back up. Kelly, go!
No.
Katie, not Kelly. Katie.
Sneak question 8. The arctangent. Remember when you,
Arctangent.
Yeah, when you Googled it. It
Correct. Yeah. So the function that's being used, if you see it on your homework sheet, it says tan -1. That's the symbol for it. It's called the arctangent. That's the function name. And me and Katie figured out if you Google arctan and then you put in the grade, it'll pop the angle out. But you have to type. It's a little specific. That's a 4th answer, but it might not be a good one. But if you do arctangent, suppose the grade is 16%. Arctan 0.16 in degrees. Google is smart enough to figure out what the hell you want.
Okay.
So there's a bunch of different ways. The easiest way probably is just to go to the homework sheet and download the one I've got linked there.
Okay.
Probably the easiest way for you.
Yeah, I got another
Okay.
answer. I got a copy. You can
Yeah.
get a copy of mine.
5th answer! Hot damn! We have 6!
For the copy of it.
For the copy of it. Yeah. They exist
Thank you.
online. I mean, here, let me just
Yeah,
show
I
you real
think I
quick.
was probably typing it in not
It's okay,
correctly.
yeah, just
I
do,
was looking, but
tangent table. And then, here, do this. And then just go to images. And there's a
I think I
bazillion
typed.
here. I mean, I think the one I used was this one. That's not bad. You can do a view image. There it is. We were using this one in class, weren't we?
Yeah.
Yeah, some of them suck. And some of them are not as good as others. Some of them have more than just tangents on them. There are other things called sines and cosines. We're going to study those on your out-of-class exams. You only need tangent for this class. So that's just tangent table. We'll do it for you. Sometimes you can probably, there's all kinds of stuff. Tangent calculator, angle from tangent, all kinds of things. But there's a couple different answers for you. I thought I saw a hand. Please, Tom.
Excuse me, I actually Googled tangent calculator and I put in my number and I got 6 digits out.
6 digits of an angle.
It would be like, the angle was like 7.665.
Mm-hmm. Tangent
But I could put in the exact tangent.
calculator. Here we go. This one right here, rapidtables.com. How about math.com? That sounds a little friendlier. Enter the opposite and adjacent angle values in the tangent calculator. Oh, this is actually backwards what we need. See, this is, the risk you run with this is we start getting into language that's outside of 105 and into 112, which is not harder or easier, it's just different. When I start talking about opposite and adjacent, that just means rise and run. But it's just different words that are used in that world. So, by all means, I'm not saying there's only one solution for these questions. There's multiple solutions. It's just a matter of tracking one of them down. That's why I like them being outside of class assessments. It gives you the time to do that. Rather than sitting in class being like, I forgot my TI, I forgot my smartphone. I think it's with myself. You know, I don't want you dealing with that stuff. I want you being able to have the time you need to get the tools that you need. Please, tell me. Go ahead.
I was wondering if you knew the answer. This is kind of off.
Yeah.
Why is it a NASA website on it? I wonder why is NASA using that?
Is that the link that I used?
Yeah.
I have no idea. Probably because I like the way it looked.
I just wonder why NASA is using
Well, if you think about when they have to figure when trajectories of things under the force of gravity, as it's falling, you can take an elevation shot, an angle of elevation, and from that angle of elevation, they can figure out how much further it has to go, knowing how far away you are. I used it when I used to teach 112. You can measure the height of Mount Hood from. I used 2 points on the Columbia River at the time, but adjusting for the curvature of the Earth. You can figure out how tall Mount Hood is to a couple hundred feet using nothing more than that transit that I had in class. Remember that thing I had in class yesterday with the. You can figure out from hundreds of miles away how tall Mount Hood is to a couple hundred feet, which is kind of crazy when you think about it. I'm remembering Ed Harris's character in Apollo 13. If you've seen the movie Apollo 13, when everything goes out the window and they're stuck up there in space leaking oxygen, and he dumps this container of supplies on the desk, a roll of duct tape and some Velcro and like a box of Cheetos, and like, here's what we got. We got to get him back. And then on the board behind him, he starts scribbling all these equations. Some of that's trigonometry, because when you have a spherical object pulling with gravitational force, there's all kinds of great constants that happen as a result of that, some of which are trigonometric. So that's why NASA would care, for lots of other reasons too. But yeah, that's one reason I could think of. Just figuring out where something's going to fall with some precision. Is it going to land in Florida? Is it going to land in the ocean? Is it going to land in my backyard? I mean, that's the kind of... When that meteor came through Russia, where the hell did that thing crash down? That would be nice to know.
Yeah.
Be nice to know if it's like at COCC or if it's in, this country or state of Georgia, perhaps.
Yeah.
So that's like difference, right? So, cool? So there's many reasons. Tangents are wonderful. GPS works on trigonometry. I mean, if anybody's using GPS on their phone or GPS, standalone GPS, that all works as a function of trigonometric functions. So it's just really neat stuff out there. Now, of course, most of this stuff you don't have to know how to do to use. I mean, when we turn our cell phones on and engage the GPS, I don't think anybody's doing a law of cosines while they're doing it. They're just walking around and trusting that Verizon's data plan doesn't shut you down. But behind the scenes, it's nice to know why some of this stuff works and how it works. Good. Now I will shut down the camera and I'll return some quizzes to you. Yes.